And welcome back to our distance learning education. Today we are going to learn the class 8 science chapter metal, metalloids and non-metal. In previous classes we already discussed about the characteristics of metal, non-metal and metalloids, and today the remaining of this chapter some useful metals we are going to describe, like first of all look at the slide. Today we are going to describe about the sulfur, the uses of sulfur. In slide you can see the sulfur. It is the yellow non-metal that is mostly used in our daily life, and its atomic symbol, or we may say the symbol, is As. In slide you can see its appearance is yellow color. In slide, please slide. In slide you can see the picture of sulfur. Its atomic number is 16 and it belongs to the group 16, period 3, block P block, element reactive non-metal. Electronic configuration is neon 3s2 3p4, and its phase is solid at the room temperature, and its melting point is 388.36 Kelvin. And sulfur is widely or abundantly found in the earth. Under the normal conditions, sulfur atoms form the cyclic octaatomic molecule with the chemical formula S8. That is, it is the S8 is the molecular formula of the sulfur, which occurs in the elemental form or molecular form. Elemental sulfur is bright yellow crystalline solid at room temperature. Sulfur is, I already told you that sulfur is abundantly found in the earth. So, sometimes it is found in the pure or native form. Sulfur on the earth usually occurs as a sulfide or sulfate metal, that is, it combined with other elements to form the sulfide or sulfate. That it has been used from the ancient time, and in ancient time it is used in Greece, India, China and Egypt. Today almost all elemental sulfur is produced as the byproduct of removing sulfur containing contaminants and from the natural gas like petroleum etc. The greatest commercial use of the element is the production of sulfuric acid. Production of sulfuric acid from sulfate and phosphate fertilizer, that means the fertilizer, inorganic fertilizer which we use in our farm is produced from the sulfur and other chemical processes. The element sulfur is used in matches, insecticides and fungicide, that is, sulfur is used in our match stick. Similarly, many sulfur compounds are odoriferous, means have some smell. That smell of odorized natural gas, grapefruits, garlic are due to the organosulfur compound. These smells due to the organosulfur compound. Similarly, H2S gas, hydrogen sulfide, H2S gas which have the odor of rotten egg, is used in other, is the characteristics of the hydrogen sulfide is odorous and which are being produced in other biological process also. Sulfur is an essential element for all life, but almost always in the form of organosulfur compound or metal sulfide, means sulfur in our daily life is mainly used in making the matchstick which we use in our daily life, that is another phosphate fertilizers and the other chemical processes. And sulfur can be distinguished due to its smell. When it combines with other and it forms the sulfide which is odorous, that is from the natural gas or from the grapefruits or from the garlic, that is it smells or it has odor due to the presence of organosulfur compound. These are the characteristics of or uses of sulfur, and this is the end of this chapter. In this chapter we discuss about the metal, non-metal and metalloids. Students, I am very sure that after finishing this chapter you are very known about the or well known about the metal, metalloids and non-metal. In a modern periodic table, metal, metalloids and non-metals are separated. That means the metals having the property of donating the electron to other, non-metal accept the electron and metalloids shares the electron, we may say that metalloid shares the electron, and metalloids and non-metals among them, if they are the good conductor they are metal, bad conductor non-metal, and semiconductor they are metalloids. These are the distinguished characteristics of metal, non-metal and metalloid. Similarly, if the substance or element is malleable and ductile, if the element is malleable and ductile then it is metal, non-malleable, non-ductile it is non-metal, and if it shows the characteristics in between metal and non-metal then it is metalloid. Remind this point, metal, non-metal and metalloids, and these metals, non-metal and metalloids are being used in our daily life in different purpose. We already discussed about the uses of aluminum, iron, gold, silver, silicon, sulfur. Gold is the precious metal which is used for the ornamental purpose. Similarly, silver, it is also one of the precious metal used for the ornamental, decorative and for making the coin purpose. Iron for the RCC framework or making the buildings, large tall buildings. For then after sulfur, as already discussed about it, silicon used as a semiconductor in different electronics. Nowadays silicon is used for making the different instruments also, and iron, that is aluminum, the aluminum is being replaced by the iron is being replaced by the aluminum due to the property of like lightness, rusting free, means rusting does not easily occur in aluminum. So, the utensils or the substances or the many equipments which are being made by the iron is being replaced by the aluminum. These are the different properties of metal, non-metal and metalloids. So, while distinguish the metal, non-metal and metalloid, so one must be very clear that if it is malleable, ductile, good conductor of heat and electricity, they are metal. And mostly metal are solid at the room temperature except mercury which is liquid at the room temperature. And if these substances are non-conductor or means we say insulator or bad conductor of electricity, bad conductor of heat, non-malleable and non-ductile, and gases at the room temperature except bromine, it is in liquid at the room temperature. Similarly, the some exception like the carbon, substances of the carbon like or amorphous substances of the carbon like diamond and crystalline form, allotropes, we may say the allotropes, crystalline form of carbon, that is diamond, and another amorphous form of carbon, that is graphite. These are the two different form of non-metal. That is, carbon is the good conductor, graphite is the good conductor of electricity, whereas diamond is the hardest substances known, although these are the non-metals. So, we may be very sure that metals, non-metal and metals can be distinguished on the basis of the above mentioned characteristics. Okay, friends, we will be talking about the metals, non-metals and metalloids in other classes too. Now, in next class we will discuss about the next chapter, acid, base and salt. Till then, have a nice day. I will be again here with the new chapter, acid, base and salt. Thank you. Good morning and welcome back. Now, we are going to learn the next chapter, that is acid, base and salt of grade 8. In this chapter, we will be, after learning this chapter, we will able to learn about the what is acid, what is base and what is salt, and their different properties. We can easily distinguish the acid, base and salt. Knowingly or unknowingly, we are using the acid, base and salt in our daily life. The way of using may be different, the way of using the compound may be different, or we may not know the substances, that is acid, base or salt we are using in our daily life. Today we will be clear about them too. For example, we eat lemon, which is sour in taste. We eat lemon, which is sour in taste, but we do not know it is acid. Similarly, as a table salt, sodium chloride, we use that in our daily life, and we do not know that that is salt. What are the properties of that sodium chloride? We are unable, or we did not know what is it. So, in today class we will learn about that. So, first we eat apple, orange, lemon, and mostly say amla that contain acid, limestone that is marble or chalk powder that is base, we may say that. It is used to paint and decorate our house. Similarly, the edible salt is salt. In this way, we are using the different types of acid, base and salt in our daily life. Let us have some example. Like for example, we are using apple, lemon, that common name cherry amilo. We are using these things in our daily life, but we are very unknown about what is this. Today we are going to describe, or we are going to learn the characteristics of these compounds, that is the substances is acid which is sour in taste. So, the word acid is derived from the Latin word acidus. Remind this point, the word acid is obtained from the Latin word acidus, which means sour in taste, which means sour in taste. So, acid is substance in Arrhenius concept. In Arrhenius concept, we define the acid as the acid is a substance which gives hydroxide ion, which gives hydrogen ion, which gives hydrogen ion, H plus ion when dissolved in water. Let us take an example, hydrochloric acid, HCl. It is the name is hydrochloric acid, HCl. When it dissolves in water, it must give H plus. It must give H plus and other is its respective ions when it dissolves in acid. We can write like this only, HCl gives H plus plus Cl minus. Similarly, other example we may take like HNO3, H plus plus NO3 minus, it is hydrogen ion. It is hydrogen ion. If the substances when dissolved in water give such ion, hydrogen ion, then it is acid. One is its basic property, we may say that it is one basic property. Similarly, all acid must have the property of sour taste. Sour taste. We can see the example like sulfuric acid, carbonic acid, etc. These are the acids which gives H plus ions when dissolved in water. Then types of acid. See, in the picture you can see that lemon. In the picture, in the slide you can see the picture of lemon. In the lemon there is some things which color is being changed to the red. That is the indicator. That indicator is termed as litmus. That indicator is termed as litmus. It has the different properties we will discuss in later classes. Then there are two types, mainly there are two types of acid. One is organic acid, another is inorganic acid. What is organic acid? What is inorganic acid? So, on the basis of sources, acids are mainly of two types on the basis of their source from which they are obtained. Source means from which they are obtained. There are two types, one is organic acid, another is inorganic acid. Organic acid means obtained from the nature. Those acids which are found in plants and animals are obtained from the nature, which are not synthesized in the lab, are called organic acid. The acids which are found in plants and animals are called organic acid. Example, citric acid, the acid which is found in all types of citrus fruit. Citrus fruit, lactic acid, tartaric acid, etc. And then inorganic acid, those acids which are prepared in laboratory or which are obtained from the minerals. Inorganic acids are also termed as mineral acid. Remember this point, inorganic acid is also termed as mineral acid. These acids are synthesized in lab, which is highly corrosive in nature too, that is hydrochloric acid, sulfuric acid, nitric acid, carbonic acid, etc. These are the acids which are synthesized in the lab. Then see the properties. Generally, the properties are categorized on physical and the chemical properties. The physical properties means, I already told you that acid must have sour in taste, but there is some exception, like some acid like stearic acid, boric acid, salicylic acid do not have sour taste. Remember one point, that is acid must have sour taste, but still there is some exception like stearic acid, boric acid, salicylic acid do not have sour taste. Another one is acid turn blue litmus into red. In previous slide we see that the lemon, in the lemon the color of something is changed there. In that slide you can see the lemon, on dipping the litmus paper in the lemon, the color is changed, means red in color. If the color of litmus is changed in red, then it is acid. See, blue litmus paper changed into red. Similarly, other indicators, methyl orange into red, and it is neutral to the phenolphthalein. Litmus paper, methyl orange and phenolphthalein are the indicators to distinguish either the given substances are acid, base or salt, and they shows the different properties in the different color in the acid, base and salt, which makes us easier to distinguish. So, mineral acids are corrosive. Another one is mineral acids are corrosive in nature. So, they are dangerous to taste. We do not taste the mineral acids, like we do not taste the HCl, H3SO4, HNO3, because they may burn our taste bud or they may have the some dangerous effect. HCl, H2SO4, HNO3, these are the mineral acids or inorganic acids. These are very dangerous to taste and touch. So, one must be very careful while using these types of acids. And the chemical properties. In this slide you can see the chemical properties. An acid react with metal to form hydrogen gas. The reaction will be like this. Metal plus an acid react with metal to form hydrogen gas, that is metal plus acid means hydrogen gas is the product along with metal salt. Hydrogen gas is the product along with the metal salt. Let us take an example like zinc, it is the metal, and the acid HCl, it is hydrochloric acid, zinc plus HCl, it is hydrochloric acid, that is metal displaces hydrogen gas from the acid and from the metal salt and hydrogen gas. ZnCl2 means zinc chloride, and this is hydrogen gas. You can balance the equation. Let us see the number of chlorine. Here is 2, here is 1. So, the number of chlorine is balanced by putting the number 2 in front of HCl molecule. Then the number of hydrogen will be 2, the number of hydrogen is 2, number of zinc is 1, the number of zinc is 1. So, it is balanced chemical equation. Before balancing the chemical equation, it is unbalanced or skeleton equation. We already discussed or we already learned about this in our previous chapter. Similarly, you can take the another example too, like zinc plus sulfuric acid, H2SO4, sulfuric acid. you can put the any types of metal here like copper, iron, then it forms zinc sulfate ZnSO4 plus hydrogen gas, this is zinc sulfate and this is hydrogen gas, and you can balance the chemical equation. First of all, count the element number of atom here in right side and left side, that is in reactant side and that is in product side. In the reactant side the number of zinc is 1, hydrogen is 2, sulfur is 1 and oxygen is 4. Similarly, in the product side the number of zinc is 1, so it is balanced, number of sulfur is 1, it is balanced, number of oxygen is 4, it is balanced, and number of hydrogen is 2, so it is balanced. The number of atom in left hand side, that is reactant and that is in product, is equal, so it is a balanced chemical equation. Another most important chemical reaction is acid react with base to form salt and water. Remember this, acid react with base to form salt and water, to form salt and water. This reaction is also known as neutralization reaction. This reaction is also known as neutralization reaction or acid base reaction, because the acid and base react with each other to form the neutral product. The formed product is neither acid nor base. So, let us take an example, hydrochloric acid, sodium hydroxide. We will discuss why it is called base in coming topics. HCl plus NaOH, it is base. Sodium hydroxide, gives sodium chloride plus water, sodium chloride plus water. This sodium chloride is common salt, or we may say that table salt, it is also table salt or common salt. Then we can take another example too, sulfuric acid, H2SO4 plus potassium hydroxide. This is sulfuric acid and this is potassium hydroxide, and this give three acid and base react with each other to form salt and water, that is K2SO4 plus H2O. K2SO4 means potassium sulfate plus water. This is water, we are very known about this. That is, the valency of sulfate is 2, the valency of potassium is 1. On crisscross, its molecular formula is like that, K2SO4, that is sulfuric acid, potassium hydroxide forms potassium sulfate and water, and the another property is like that, acid react with base to form salt and water, and another one is acid gives hydrogen ion. We already discussed about this. Acid when dissolved in water must form H plus ion, when dissolved in water, like this. These are the acids. So, acid HCl forms H plus plus Cl minus, H2SO4, H plus plus SO4 minus minus. This must be the acid when dissolved in water must give H plus ion, And the last one is acid react with metallic carbonate. To produce carbon dioxide. Acid react with metallic carbonate to produce carbon dioxide. Let us see, this is our last chemical reaction, like this, HCl plus metallic carbonate, calcium carbonate, limestone, it forms calcium chloride then water plus carbon dioxide. See, HCl, acid, this is limestone, we may say that metallic carbonate, its name is calcium carbonate, and gives carbon dioxide and on balance, while balancing this chemical equation, see the number of calcium, carbon, chlorine, hydrogen and oxygen. Remember this, while balancing, the number of hydrogen must be balanced at last. The number of hydrogen must be balanced at last. And this is the summary of the chemical reaction. In slide, please slide. This is the summary of the chemical reaction. Acid plus metal, salt plus hydrogen, acid plus metal hydroxide, salt plus water, acid plus metal oxide, salt plus water, acid plus metal carbonate, salt plus H2O plus CO2, acid plus metal hydrogen carbonate means bicarbonate, acid plus carbonate, bicarbonate similar, salt plus water plus CO2, acid oxide plus base gives salt and water. And these are the uses of acids, which we will be discussing in our coming classes. Till then, study about the uses of acids and some terminologies about the base. Till then, have a nice time. See you again. Bye.